Hello, everybody. My name is Oprisnik. I'm a software engineer in our Facebook London office, and I work on our images infrastructure for Android. Today, I will talk to you about Fresco, which is our image loading library that we have open sourced 4 years ago, and what happened since then, how the library changed and how it evolved, and what we did internally to improve it and to work on performance. But first of all, let's talk about what is Fresco. So as I mentioned before, Fresco is an image management library, and it makes it easy for you to load an image in your application. And it also is focused on performance, especially for low-end devices and mid-end devices. So one of our focuses was on Gingerbread back in the day when Fresco was actually open sourced, and until now we still support Gingerbread. So today in this talk, I'm going to walk you through, as the title says, what happened in the last 4 years, what we did internally to improve the library, what we open sourced, and what we have been working on since then, since the library was open sourced. And I want to start with walking you through what we actually did. So first of all, I hope all of you can see this. So there are going to be lots of bullet points on this slide. Points in blue will be things that I'm going to be talking throughout this slide, throughout this talk. So in 2015, Fresco was first open sourced, and we worked a lot on performance optimizations and adding new features and improving the library size, like the modularity of the library itself. In 2016, we open sourced Fresco 1.0, so we found that the library is mature enough that it can be a 1.0 release now, which added support for custom image formats. So like you can, for example, have your custom format for whatever you want to have, like SVG. And we also improved our debugging tools. So we added, for example, a debug overlay. 2017, we mostly focused on performance. So for animated images, for native rounding, and also on our sample apps so that it's easy for people to test what's going on and to see how our library works. 2018, our library was relicensed from Apache plus patents to MIT, which was in line to most of our other open source libraries at Facebook. So now we are licensed under MIT. And we also improved how we load native code and worked on modularity in general to make the library more lean. Then fast forward to this year. So the first point here is Fresco 2.0, which is the main thing that we released. But don't get too excited. This was mainly caused by us moving from the Android support library to Android X, which is a big breaking change. And we had to bump the major version number. However, the thing that you should be excited about is the last bullet point here, which is the improved APIs and components, which is one of the things I'm going to talk about later. So overall in this talk, I'm going to have 4 main sections. So I'm going to start with how does Fresco work, what does it do under the hood, how can you just reuse some of the components that we have. Then I'm going to talk a bit about the modularity efforts, how you can trim down the library, how you can only use what you need. Then something for all of you is how you can improve image performance in your applications using tools that we have and like things that we found in general when we work on image performance on our applications. And finally, the last point is how we improved our APIs and our UI components to be more flexible and to be easier to use. So let's jump right in. First of all, how do we draw images? So in Android, this is just one class, the bitmap class, which is quite what the name says, is for each pixel, you have the color value of that given pixel. If you want to get to one of these, so you have an encoded image and you want to get a decoded image. So unfortunately, for some reason for the slides, there should be an arrow between those, but those arrows, the gray color doesn't show up on the projector. But just imagine here that there are arrows in between. So we go from an encoded to a decoded image by using something called a decoder. This is how it works in general. This is what everything has to do. So the encoded image is a compressed version of the image, which is much smaller. And then we have to decode it and get to the decoded pixel data that we have to display. So in practice, this is mostly JPEG, which is what most cameras take. It's a good encoded image format that, for example, most of the phones take nowadays. And also PNGs, which we use for local assets, which have transparency or which have to have like graphic content. So one thing that is hard when you actually want to load an image is the size of the image. So for example, here, if you have a JPEG, it's roughly between 2 to 4 megabytes if you have a 12 megapixel picture from, for example, a Pixel phone. But then we have to decode this to a bitmap, and the bitmap is, again, raw pixel data. So like for each of the pixels, you store the color value, which would be 4 bytes per pixel. So in total, if you want to decode that to a bitmap, that bitmap would take 46 megabytes, which is quite large. and which was one of the focus areas that Fresco was developed upon, which was to efficiently manage the memory, and especially for low-end and mid-end devices, which again, back in the day was Gingerbread. So Fresco tries to efficiently manage that memory and make sure that everything works properly. All right, so how do we actually do this decoding? So Android actually provides us with a couple of methods here. So the first one is the bitmap factory, where you can just load a bitmap from an encoded image. And also recently with API 28+, they added a new image decoder class, which is similar to image loading libraries. It has support to decode bitmaps or drawables from a given encoded image. And also the Android system out of the box supports quite a few formats already, like the most common ones, bitmap, GIF, JPEG, PNG. But if you want something else, for example, WebP, it really depends on the platform. So for example, for decoding WebPs, it was only added with Android 4.0. And if you need more advanced features like lossless WebPs or transparency, it's 4.2.1. And for newer formats like HEIF, it's even only API 8.0+. So Fresco does support all of these image formats if they're supported by the system. We just use the bitmap factory to actually create a bitmap. But on top of that, we also optionally add support for more image formats. So for example, for the WebP example from before, Fresco, if you add the WebP dependency, the WebP support dependency, can display WebPs down to Gingerbread, all of the variants, like lossless, simple, everything that you want to do. And in addition, we also have support for animated GIFs, animated WebPs, or, as I mentioned before, any custom image format in general. So we have a sample application, and in the sample application, we have, for example, SVGs, keyframes, and like some simple color example where we just decode a color value. So how does Fresco do this under the hood? So we have the encoded image and we have the decoded image, which internally is represented by just a simple encoded image, and the decoded image data is something called a closable image. So why closable? Again, as I mentioned before, Fresco tries to be smart about memory management. So what we do is we do manual memory management, and as soon as we don't need image data anymore, we can close it. This is why this has to be a closable image. And then we have an image decoder class which performs the hard work. So if you want to add your own format, like for example, any format that you would like, so you would just define a new image format, which is one of the classes that Fresco provides. You would define your header bytes, like every encoded image has a header, which includes which format do we have. And then you would just create a new format checker, because we need to determine for each given encoded image what is the format of the image before we can decode this. And this one just has two simple methods. One to get the header size so that we know how much we need to extract for you. And the second one where you would just determine the format. So in this simple case, we have some utility methods where we just check if my given header, if it starts with my given header bytes. If it does, I return my custom image format, and otherwise I don't know what to do, so I just return nothing. And finally, if you want to decode that image, so what Fresco is doing, it determines the format, and then based on that format, it decides which image decoder to use. So in this case, it would use your custom image decoder, and you have just to implement a simple decode method. So this decode method has the encoded image, which has the image stream, like the input stream or whatever you want to get. Some other parameters that we do not care about too much, except for image decode options, which are some additional parameters where you can define some transformations and other things, which I'm going to mention later. And you just return the closable image if you can actually decode the encoded image, or nothing if you're not able to for whatever reason. And you could do something like you can just create a bitmap from whatever decoder you have. Like if you have a native library or something, you just create a bitmap and then just return a closable static bitmap, which is our internal representation for a bitmap class. And it's called static because we also have support for animated bitmaps, which are not static, basically. So, but all of this right now only works for local assets. So like we assume that we already have the encoded image somewhere. So, but what about remote images? This is what most of you are using. Like you have a URI somewhere in the server, you have an image, and you want to actually download this. And in addition, we also want to glue all of the things together, like the decoding parts and all of this. And this is what the image pipeline internally is doing. So we have a couple of layers of caches. Again, unfortunately, the arrows here are missing, but there should be an arrow where you go from the request to the decoded memory cache. So what we do is we send an image request off, we go to the decoded memory cache. If the image is in the cache, we immediately return the image, the decoded image, and you can use it. The next step is if the image is not in the decoded memory cache, we have a second layer of cache where we store the encoded images, which are much smaller, but still it is efficient to keep the encoded images in memory. And if we find it in memory, we just have to do the decoding. Each encoded image has an image format based on what we saw before. So we just pass it to the decoder, decode it, and put it in a decoded cache, and then it's passed on to the user of the image. If that fails, we also have a disk cache. Again, same thing. So we check if the image is in this cache. If it is in this cache, we read it to memory, to the encoded memory. We do the decoding. We read it to the decoded memory cache, and we pass it on. And if none of these happen, we go to the network. And once the network result is returned to us, we put it in a disk cache. One additional thing is the transform bit here that, again, where the arrow is missing. But what Fresco also can do is it can transform an image when it gets the network data. So the question is, why would we want to do this? A good example is, again, before I mentioned, for example, the WebP format that is not natively supported on some platforms. So what Fresco is doing is it takes the WebP format, it transcodes it to a JPEG or to a PNG, depending on if we need transparency, and then passes the PNG onto the library, and then the system can handle it as a JPEG or as a PNG image directly. This is one of the options that you can set up. And one other thing that our library is doing is that only the first part is done on the UI thread. So we only check if the image is in the decoded memory cache on the UI thread. For everything else, we have lots of different thread pools, depending on the job that has to be done, and where we have some job scheduling where we make sure that everything works. And also in general, this is a much simplified form. So in practice, we also do some deduplication if you send multiple requests, and we have lots of other logic and steps in between to optimize. And one more thing is also the decoded and the encoded memory cache. The data in there can live on different, can be in different layers. So for example, you can have them in Java heap, in native heap, on ashmem, depending on the Android version. All right, so how do you actually use this? So you just call Fresco get image pipeline, and then you fetch the decoded image. As I mentioned before, you send an image request to the library, here just for a given URL. And you can also optionally pass something called caller context. I'm going to come back to that later. For now, we can assume the second parameter is just null. So the return value that you would probably expect here would be a closable image, right? But unfortunately, that is a lie. So the actual return type looks something like this. So you get a data source of a closable reference of a closable image. So some people might ask, but why? Like, why don't we just get the closable image? And I'm going to walk you through why Fresco works that way. So the closable image, we already discussed this, is just the decoded image data. If you have a bitmap, it's a closable static bitmap. But also, as I mentioned before, Fresco is doing manual memory management. So we need to do some kind of reference counting to make sure that we can properly close the image when it's no longer needed, when nobody has a reference to it, which is why we have close a reference. So what you do is, if something needs to hold on to the image, it has to clone the reference. And if you don't need the image anymore, you close the reference, which is basically internally doing some reference counting. And if the count reaches 0, we can clean up the memory, or we also have, for example, bitmap pooling. So we have pools of bitmaps, so we can put them back in the bitmap pool. And finally, the data source. This is basically an alternative to Java Futures built for the image pipeline. But unlike the futures, so what this one is used for, it can have multiple results. For example, one of the features that Fresco has, it can display progressive JPEGs. And a progressive image means we have a low quality, a medium quality, a high quality image. So instead of having one image result, you can have multiple results, which means you have to have a data source that can supply multiple closable references of closable images to you. All right, so now that we know the return type of this, what we can do is we just get the data source, and we can just subscribe to the data source to get notified when we actually get an image. We have some convenience classes here that make this a bit easier for you. So in this case, you would just implement, now we get a new result, you get the data source, and then you can do whatever you want with the image. So for example, if you would like to write your custom UI components, you can manually use the image pipeline here to get a closable reference to the closable image, and then you can display this within your custom view or your custom component. And once you no longer need this, you just close the result, and everything should work. And if something goes wrong, we also have the same thing for a failure. One additional thing that the data source has, it has a failure reason, so you can actually check why was the image not displayed or downloaded. For example, if there's no network connection or if something else goes wrong. And the final line here is you also can specify which thread you want the results to get. So in this case, I just want to get it on the UI thread immediately, but you could trigger that on a different thread as well. If you're just interested in the bitmaps, we also have a convenience class here that directly gives you a closer reference of bitmap. It can also be null because, again, the closable image can be anything. For example, we could have a vector graphic, which would not be a bitmap. So you would only get a result here if the image is actually a bitmap, like a static image. All right, so I mentioned before that you can use this to build your own UI components, but this is quite cumbersome. So how can you actually draw the closable image on the screen? And also, you probably also want to have more advanced features. For example, you want to have a placeholder, you want to have an error, overlay, progress image, like all kinds of different images. You also want to do scaling, you want to do rounding, fading, like all kinds of effects to make the image experience nicer. And finally, when do we actually release the image? Like I said, you have to have manual memory management, and you have to make sure that you close the image once you do not need it anymore. So this is the second part of Fresco, which is the droid part, which are our UI components. And if you take a look at our documentation, you can find that droids are spaces in which images are rendered. And it follows roughly an MVC pattern. So it consists of the three parts here. So let's start with the view first. So instead of having a simple image view, for the droid components, you do need a droid view. This is mainly needed to be able to see when the image is on screen and off screen. We need to have some kind of callbacks to see now the image is not needed anymore and we can free the memory. And this works down to Gingerbread. This is why it was introduced with droid. The second one is the droid hierarchy, which is the model, which is actually quite simple. So it is basically just a list of images, like layers stacked on top of each other. All of them are optional except for the actual image, which is the actual image we eventually want to display. And everything is wrapped in a fade drawable where you can fade between layers, and you can have overlays, failures, retry, and everything you want to have. You will build it something like this. So if you have a droid view, you can set the hierarchy for the droid view to, for example, have a placeholder image, to have a scale type here. We have a custom implementation for scale types because we also support more complex functions like this one here, where you can have a focus crop. So what this one would do, you can focus to a given point in the image. You specify here it should be 20%, 40% of the image, and then it will focus on that image. Or you can implement any custom scale type as well, so that you can do any matrix transformations, basically. And also, the hierarchy supports things like rounding, where we would basically, in this example, have a fully circular image. And finally, we have the controller, which just interfaces with the image pipeline, doing exactly the calls that I just showed you. It subscribes to a data source, and it just handles the result. All right, so this is the main library. This is how Fresco works, how you can use the droid components, how you can use the droid hierarchy to set up your image. Now I want to talk about the second part, about the modularity of Fresco, which is one of the themes that we saw in the beginning throughout the history of Fresco. So actually, Fresco is not just one package. So actually, we do publish 23 different Maven artifacts to our Maven repositories. So because we do have lots of functionality, and over the past couple of years, we made lots of those things optional, and you can decide what you want to include in your application and what not. So this is a list of all of them. I'm not going to go through all of them. So the main one is the top one, which is the main Fresco one, which is a subset of those, which we think is a good baseline that everybody needs. And we have lots of them, from like image formats to stuff for the image pipeline, for some native code, some for WebP support, and like lots of other things, basically. And you can also just pick some of them. So for example, if you want to build your own UI components, you can just pick the image pipeline dependency and not include anything else, and then just build your own UI components on top of that. So one thing that I mentioned here is Fresco does also use native code. So the reason for this is that Fresco, first of all, we need to support some image formats like WebP, animated GIFs, and those can be loaded using native libraries like GIF libraries or like WebP libraries. And we also do this to store the encoded and decoded images on native memory. So we have to have native code dependencies in Fresco. And in order to load native code on Android, we have another library called SoLoader, which we use internally to actually load native SO libraries in our applications. So the reason why we have SoLoader is it makes it easy for unpack your native libraries and dependencies on platforms that do not support them out of the box. It has like a bunch of bug fixes and like additional functionality to the built-in system version. And a while ago, we made the decision to make SoLoader the default for Fresco. However, we got quite a bit of feedback from the community that like people want to use different implementations. They want to use the system one or like other implementations. So now we can announce that you can actually do that again. So starting with Fresco 2.1.0, which is going to be released soon, you'll be able to just exclude the SoLoader, and then it will fall back to the system version. And we also added an abstraction between like native code loading, so you can just implement a native loader interface and do whatever you want. If you have any implementation, you can just hook that up. So this is about native code. This is one of the big things that we have been working on, but one of the other big things is, so the native code is mostly needed if you have backwards compatibility, like maybe down to Gingerbread, which probably not too many of you still have, or if you need some special image formats like animated GIFs. But for all of these things, we started to actually also work on Java replacements. So now you can also use a Java-only Fresco version, which is going to be much smaller. The build setup is going to be easier, because for native libraries, what you usually have to do, what we recommend is that you have to have ABI splits depending on your targets. Like if you have an x86 device or ARMv7, you should have different APKs. With the Java-only version, if you're okay with the performance hit that you're going to get by not having the full native implementations that usually make things faster and are there for a reason, you can now do this. So again, with the version 2.1, you can just exclude all the native code things. We are also going to publish, maybe make this easier in the future for you to use. All right, so the third part is, if you use Fresco, or in general, if you're working with images, even if it's not Fresco, how can you improve the performance of your images? So there are basically two big things. The first one is prefetching. So what we can do with Fresco is you can also trigger a prefetch. So for example, you can tell Fresco, I'm pretty sure that I'm going to need this image in a while, so just prefetch it for me to the disk, which means that once you actually need it, you can immediately get it from the disk, or as in this case, from the bitmap cache. Also, if you have, for example, a scrolling list, you probably, if you scroll fast and the image goes out of the viewport again, you can then cancel the prefetch because you're likely to not need that image anymore. So this is one of the things that you can build into your UI components in whatever way you want. One thing that you have to make sure, though, is that you prefetch the correct image. So for example, if you have a square image that is like, or if you have different image sizes and you prefetch a wrong image, you're going to have both of them in memory because the images are not going to be displayed. Or for example, if you resize the image and if you do not resize so if your UI component used to resize the image, but you do not resize when you prefetch, you would prefetch a huge image and then also do the resizing later. So you should already set it up properly so that the actual image is fetched. Which leads me to the next point, are my images properly sized? So this is probably the bigger thing that you can easily do in your applications. So if you look at this example here, this is the showcase sample application that we have for Fresco, which has tons of examples, which you can just build if you check out our repository. One of the examples here is the recycler view, just a list of images, basically. So do you know if those images are appropriate for the given viewport? It's really hard to tell if the image is too big or if it's too small or what happens. So we do have a debug overlay, which makes this easier. What you can do is, when you initialize Fresco, you can create a droidCon config, because this is specific to our Droid UI components, because we need to modify the UI. You can just have a supplier where you say, in your debug settings, for example, you can have a toggle, and if you toggle that, you're going to have a debug overlay. And as you can see here, you see lots of information in there where the image comes from which cache, and you also see with I is how big the actual image is. So in this case, for example, the image is 800 by 800 pixels, but the viewport, the drawable with D, is only 474 pixels. So like in total, you're loading 4 times too many pixels, which is one of the big optimizations that you can do. We also have a second tool that you can use for this. So we also have a tool called Flipper, which is a desktop application which can have all kinds of plugins to make debugging your applications simpler. And we also recently open sourced our images plugin. And you can use this with, for example, our Showcase sample app. Again, if you check this out and if you install Flipper, it should just work. And it shows you, again, in which of the caches, what images you have in cache and what's going on. And probably quite small here is on the side. You can also see some details if you click on an image, like the dimensions, again, the URI that was loaded, and all of the other things. And one thing that is hard to read here is there is also one field for attribution. So one thing that we are also using, or what we are supporting with Fresco, is you can attribute your images. So it can be really valuable to know if you, for example, have some logging, or if you look at any debug information to see what image caused a given issue. So the second parameter that we saw before, the caller context, is basically that. It can be any object, it can be any debug information that can be used to identify your image. So for example, if you have two draw views and if you load the image, you can just set image URI with a given URI and then with the caller context that you want to specify. So in this example here, we have two of them. The first one is a circular image, so I set the caller context to be circular image. And for the second one, I set it to be rounded corners. And then in the Flipper plugin, you would see here that for the attribution step, you would have the circular image for if you click on the circular one, and you would have the rounded corners for the other one. And the third thing you can benefit from in terms of image performance is to benefit from Fresco performance improvements, like things that we do under the hood to make things more efficient. One of those was we introduced faster rounding. So there are basically two ways of how you can round an image on Android, or there are like multiple ways, but there are two main approaches. So you can either round at render time, or you can round the image at the decode time when you get the bitmap, and you can just clear out the pixels. So most applications usually do this at render time. You have a bitmap shader, or like you have a drawable, or you draw something outside. But we found that we actually, if we do this at the decode time, by using one of the native C++ implementations, it is significantly faster to do so. Yeah, and it's much, much faster and much more efficient if you do this just once. You also get the benefit that if you re-render the image, you don't have to do the transformations again, because you did this once only when you decoded the image, and then you put it in the caches. So overall, this is a really good thing to do. So how you could do something like this yourself is we have a bitmap transformation API, which is also fairly new, where you can have an in-place transformation for a given bitmap. So in this case, what you can do is in the transform method, you would call your native rounding filter that just does some native rounding. And you can also specify anti-aliasing if you need that, or if you like draw an outline, you probably don't need that, then you get even more performance benefits. So, but if you come back to the model that we had before, so we had the hierarchy and the controller, basically. So when we moved from doing the rounding at render time to doing the rounding at the decode time, we faced a problem. So for example, if you have a placeholder, it's pretty simple. We talked about this. The placeholder lives in the hierarchy because this is the layer of images, so you just set this here. The URI is what you fetch the image for, so this one goes to the controller because the controller interfaces with the pipeline. But now, if you do the rounding, where does the rounding go? Like it used to be that we did this at render time, just the hierarchy would set everything up, it would perform the rounding. But now we have to do this at the controller level, and in practice, you can do this at both. So this basically surfaced some problems with how everything was well structured and how we had like a clear separation between UI components and the pipeline and all of these things. And if you look at the code for this, so if you want to do this with the draw hierarchy, you would just generate a new hierarchy, you would set the placeholder, you would set the rounding parameters, and everything would be set up. But if you want this for the controller, since we didn't add specific APIs for this, you would have to do something like this. So you set the controller, you would create a new droid controller builder, which again gets the image request, which has some image decode options, which is the second parameter that I mentioned when I explained the custom decoder. And there you can set your bitmap transformation, where you would set your circular bitmap transformation and build all of that. So everything is really nice and separated. We could have added new APIs for this, like we could have just been like a controller, do the circular rounding and everything. But what we decided to do a while ago is to rethink how we are doing the APIs. And we also looked at what other libraries are doing, what basically works for other teams. So one of the things that a lot of libraries are doing right now is they have a declarative API. So instead of knowing how stuff works under the hood, you just declare how things should look like, and the library will figure out the rest. So one example here is Litho, which is another open source project that we built at Facebook. So with Litho, you would just define how the layout should look like, and then the framework would figure out all the rest. So in this case, you would just have, I want to have a text which says hello Litho, and a text color with a given text color value, and I don't care how anything works under the hood. So this brings me to the last point, which is the future of Fresco and what we have been working on. So ideally, it would be nice if you could have something like you have just a view and you just do show a given UI. So now you can actually do this. We have been working on some new UI components called Fresco Vito. So what those components are doing is we simplified a lot of those things. So first of all, the first example was just an extension function for Kotlin, but under the hood, it will go to some class called VitoView, which you can use from Java as well, and you would just show a given UI into a view. And yes, this is just a simple view. So with Vito, we do not have the requirement of having a custom view anymore, like we had with the droid view. You can just use plain views, or you can use an image view if you like as well. So like this was also one of the pain points when people migrated between libraries, that you had to switch the view implementation. Now you don't have to do this anymore. So in general, we did take a step back and looked what are the important parts if you want to load an image. So the first one is, what do I actually want to display? The second one is, how do I want to display this, how it should look like? The third one is, where is it actually displayed? So again, the attribution that we discussed before, and when is it displayed? So these are the four main points that you need to know, or that you want to know when you load an image. So for the first one, we have the UI. We also have a feature called multi-URI, where you can specify a set of URLs. So you're going to see an example later. How to display, we added a new object called image options, which is similar to like a style, basically, an image style. When it's displayed, we keep the attribution, what we discussed before. It's just an object. You can have any metadata. And we have also listeners so that you can be notified when something happens. So let's take a look at the image options. So this would be a really simple example. Again, from before, we were not sure where we would do the rounding. So now what we would do is you would create new image options, you would set the rounding, and you would just pass that object to Fresco, and Fresco would figure out the rest. If you look at a bit more complex example, like we also support basically most of the features that the droid components had. So if you have a placeholder, we had the placeholder in here. And if you want to add a border, you can just add like some border options, for example. And then if you want to show this, you just do view, show the UI with my given image style. One other advantage of this is that this is better for performance, because what you can do is you can reuse the image options. So because these image options are immutable objects, you can just define a style once. Like for example, if you have a profile picture, you could define a profile picture style and then just pass this to all your components that actually display the profile picture, and they all will look the same. So we talked about view support and all of this here, but our main focus actually was litho support. So I mentioned this before. What we found is that we can improve on our previous litho components that we had. So we spent some time working on Fresco Vito image specs, which can be used specifically if you're using litho. And again, what you would pass here, you would just pass the same four things. So you can pass the UI, you would pass the style of the image, the attribution, the color context, and some listeners. So if you want to do, for example, some performance logging, what we also support is we have like an image performance logger, which you can just attach to an image, and then you will get detailed data, how long it took to actually load an image, or what happened in between, where the image came from. Like we have a good listener interface for this available that you can hook up as well if you're interested in that. And if you also properly set up attribution, you also know where the image is coming from. Like you get a clear picture of what's happening in your application. So if you take a look at the image options here, as you can see here, so this is like a Java example to switch it up a bit. We have some profile picture options, and how they could look like is you define statically once your profile picture options with a given placeholder resource and an overlay resource. One other thing is that what Fresco can do if we have this definition of just resource IDs. So what Vito will do is we will lazily load a placeholder only if it's needed. So for example, if we know that the image is already in cache, we're not even going to inflate the placeholder image because we don't know this, because we don't need this, sorry, which is better for performance. And then we also have some rounded profile picture options where you can extend them. So another feature is with image options, you can extend from given other image options. So we would have a base style, for example, and then for the rounded version, we would just extend and add the rounding parameters. Or like another example, you can have the same scale type. This is the same example that we saw before with like our custom scale types, all of that. And you can extend it to have, for example, a colored placeholder. If you have a dominant color of your image, you can just extend the base style and have the color. And if you really have to have a custom drawable, you can still set custom drawables as well, of course. So one more feature that we have is the multi-URI feature. So as I mentioned before, what you can do is you can give us a list of URLs. So for example, here you can set a low resolution image request URL, and then you can also set a list of other URLs if you have like different variants of an image, and then it will show them the first one that is available for those. So it will show the low resolution version and until the high resolution version is available. One other thing that we simplified is how we do prefetching. So I mentioned previously that if you want to prefetch, you have to make sure that you actually prefetch exactly the image you're going to display, which, for example, for the rounding case is quite hard because you need to know you're going to round the picture. Otherwise, you would fetch the square image and also the rounded image, so you would have two images in memory, which is not great. So now our prefetch calls, they just take the same parameters. You just define the URI and the image options, and additionally, if you want to, the color context. And you can do this to disk or to bitmap cache. So if you recap, our old components used to have those three blocks. And now we have something that we slightly modified. So we still reuse lots of the building blocks that the Droid version had. But now we only need to have a view instead of a Droid view, or a litho spec if you're using litho. Instead of having one controller and one controller builder per image, we just have one global controller, which you can also customize, that orchestrates everything, the whole image loading process. And instead of the hierarchy, we have a mix of the image options, which you define, which is the image style that you have. Everything works internally based on the Fresco drawable, which is a more lightweight version of the hierarchy that we had before. And of course, we need some state. Like, if you're doing image loading, at some point, you have to keep track of some state. So we also have an internal state that we keep track of. So the question is when you can use Veto. So actually, the code is available on GitHub already. So you can already check out our repo, and we have lots of samples in our showcase application where you can play around. So for example, here we're using the litho sections framework to have some litho components defined. And we also have lots of other examples like here where you can customize the image options, where you can play with different parameters. Like here I'm doing a black and white image and some border and some rounding, and you can just play around with this. All right. That was basically it. I wanted to still point out that we do have lots of documentation available on our website, frescolib.org, if you're interested in more. If you have any questions or any comments, please file a GitHub issue.